Now it's time for the official theorem. We're going to call this one Theorem 2.12. It's fully in the book. I think I'm giving most of the information over here. This is going to be how to find the center of mass of a lamina. We finally get to use some calculus. Okay, so let F be continuous and non-negative. Again, if it is negative, that's fine. We just break it up into the positive and negative portions and work with it from there. With density rho, and actually I'm pretty sure, no, yeah. I'll talk more about why we're assuming non-negativity here. Density rho and lamina formed by the region R, which is just under F from A to B. Then, the mass of the lamina, we already found it. This is just restating what we did in the last video and having it a little neater. The mass of the lamina is just rho, the density, times the integral from A to B of this function. And again, this is just the area times rho. Right? Mass is just area times density. Well, this is the area. That could have been a bit of an easier way of coming up with this, right? Mass is area times density. Anyway, that's fine. And the second thing, the moments, the first moments, or both the first moments, are m sub x, the moment with respect to the x-axis. Again, has to do with y coordinates. That's going to be rho times the integral from a to b of f of x squared over 2. Actually, I'm not going to write this the same way the book does. I'm going to write it my own way. F of x squared divided by 2. The 2 can come out in front, though. Dx. All right. That's a moment with respect to the x-axis and is useful for calculating y bar. And the first moment with respect to the y-axis is not the same. It's just rho times the integral from a to b of x times f of x dx. And finally, the center of mass, or the centroid, remember for a lamina, they're the same, is x bar y bar, where x bar is just exactly what it was before. Mi over m, and y bar is mix over m. So this is old. This is kind of old. This is new. You're going to need this in your notes. Definitely. You're not going to have to memorize it, but you will have to have it written down. Okay, that's what we've got here. That's what we're going to use for this example problem. Example 3. Let R be the region under f of x equals the square root of x on 0 to 4. Find its centroid. And again, hopefully our answer kind of makes sense. If we're drawing a little graph, all right, square root of x, this shape, 0 to 4 means that we have the point 4 comma 2, and it's the region under f. So it's that region. So just right off the bat, where do you think the geometric center of this region is? Centroid is that geometric center. It's the center of mass of that lamina. The lamina has constant density. They're all kind of related quantities. So I don't know, maybe it's here or something. Maybe kind of 3 comma 1. No, it's going to be lower, right? Like 3 comma a third. No, 3 comma 2 thirds. That's my guess. 3 comma 2/3 is my guess. I've been guessing real well today. Let's see if my streak continues. But they keep getting harder. All right. Hopefully you have your own guess. No, I'm not going to spend time making the guesses. The more you succeed, the more you have to lose, I feel like. If I just failed the other ones, I wouldn't have thought twice about getting a good guess. Let's just do it. So we need X bar and Y bar. X bar is the moment with respect to the y-axis over m. And y bar is the moment with respect to the x-axis divided by m. So we need these moments, we need the masses. That's a lot of integrals, guys. Okay. M is the area under the curve times the density. Jason, you didn't tell us the density. Well, it doesn't matter. Right? This has a row in front of it. This has a row in front of it. Row divided by row. There's a really bad joke about rowing your boat gently down a stream, but I'm not going to make it. The rows cancel. M is going to be row, which we don't know. It doesn't matter. Times integral from a to b of the function. It's just the density times the area. We can calculate that. All right, the moment with respect to the y-axis, that's going to be rho times the integral of f times x. And the moment with respect to the x-axis, just rho over 2, integral of the function squared. Making sure I wrote it down right. So just calculate all of these, divide them, and you get your center of mass. That's it. That's the rest of this video. Now, if you want to stick around and get the answer, you can, but that's all the new stuff. I recommend you pause the video, calculate these integrals, and let's see if we get the same thing. Whoa, hey, and don't drop your pen. I wish I could blame that on October, but I can't. Let's do each one of these in colors. I like colors. Let's start with some red math. Some red maths. Maths. Anyway, this is rho times the integral from 0 to 4 of x to the 1/2. We use the power rule. X to the 3/2. 2/3. From 0 to 4, we get 2 rho over 3. 4 to the 3/2 minus 0 to the 3/2. 4 to the 3/2. That is 8. We get 16 rho over 3. Great. The center of mass, the first moment of the system with respect to the y-axis is rho times the integral from 0 to 4 of this. That's x to the 1 times x to the 1/2. That's x to the 3/2. Again, use the power rule. Add a power, divide by the power from 0 to 4. We get 2 rho over 5. Square root of 4 is 2. 2 to the 5th is 32. We get 64 rho over 5. And lastly, the moment with respect to the x-axis. Oh, I like this one. X dx. Rho over 2 times 1/2 x squared from 0 to 4. You get rho over 4 times 16. I'm writing behind my head. Writing behind your head would be impressive if it were in a classroom. It's less impressive on a tablet. So, I really want to fit this all on one thing. What's the center of mass? The centroid. It's x bar, y bar. X bar is my. And if you get these flipped, hopefully you'll be able to see. My, the blue divided by red. Oh, I can't do that in my head. I'm going to use a calculator. Blue divided by red. 64/5. divided by 16 over 3. That's 2.4. Well, I guess 3, but it was 2.4. And the other one is just going to be 4 divided by red, which is 3/4. I guess 2/3. Not far off. All right, so if we really wanted to do it, right? 2.4 is a little bit more than half. 3/4. Oh, wow, interesting. And so if you flipped these, right? If you thought that the X bar uses the green, you should hopefully get a very obviously wrong answer. If you flipped things, you get that the center of mass was like 3/4, comma 2.4. You get that the center of mass is right here. Alarm bells, woo, woo, woo. That's not right, okay? Your center of mass should kind of make some sense. And it's even a little bit better when you have a real graph, right? Like if we're graphing y equals the square root of x, and we're looking from 0 to 4, let's make the y kind of make sense too. We have that our center of mass should be 2.4, comma 3/4. That orange dot should be in the middle of all that area. And with this picture, yeah, it looks a lot more believable. All right. I'm sure there's a way on Desmos to highlight this whole area, but I don't know it off the top of my head. But yeah, if we think of this as an actual mass, I could believe that it could balance on this orange point. I'd believe that. Always make sure your answer makes some kind of sense. That's it for this video. Let me know if you have any questions. Good luck. Bye-bye.